If you watched the series of videos where we were constructing this Java-like string class and its implementation, we've used const keyword a lot. In fact, we used it almost constantly. So for instance, if I try to select it in my source file, you can see how persistent it is and how many places, different places, we used it. So just a few functions, but almost every other function has its const keyword used. So right here, one of the very consistent uses of const should be with references. For example, this is a constructor of our class string. One of the constructors that we use. We have a number of constructors. We have 5 of them actually in this current version. And in one of the constructors we pass string view, which is like a constant string in C++ library, as a parameter to this constructor. So it's convenient to do two things. Number one, if there is an object string view existing somewhere, we don't want to make a copy of it just to call this constructor. So this constructor has its own string view, and the string view, like this string view object right here, all we want to do is just to populate it with reference to another string view object. So of course we want to avoid making copy of that object and then use copy in this single place only to initialize our own string view object inside the string. So we want to avoid copying. This is done very simply. You just use a reference, right? So you just say, let me just temporarily get rid of this. So to prevent copy of some other object which will be given to this constructor to use to construct its own copy of string view, right here, all we need to do is do this. If we did not do this, then we are making a copy. Remember, all values, all parameters, all function parameters, not using pointers or references, will make copies of things. So if this string view is a huge object, which could be like taking megabytes of space and memory, you will be copying these megabytes of memory to over here to just use it only once, and this is a bad choice. So we quickly remember that we have references. So the reference prevents from making copies. But with references, almost in more than 50% of cases, remember to use const. So what we just did is that we're saying that string view is a reference to constant string view. Therefore, this string view, compiler will make sure that we don't do anything anything that would change the state of this other string view that came from outside. And in many situations, when we do something with references, perhaps we would like to ask compiler to watch out that we're using a reference to these other objects in a read-only mode, so that we don't change them. And this is why using this combination of like a reference to constant something is a much preferred way. Only if I need to start calling functions inside string view that would modify its state somehow, only then I would get rid of this keyword. So for me, the default version of reference when I add references to function parameters in my coding is always to think const about these references that are coming from other places in the application. So here let's make a look and see there's this another. In fact, I can add ampersand to this, and you can see all places where we're using this technique, right? So we have our function. So here, for instance, this is concatenation, which wants to concatenate this string with another string. So what we do here is that we say that this another string object will be getting access to it but we prefer to make sure that we use it in a read-only mode. We don't attempt to modify anything. So this makes the code much safer. This makes compiler again able to optimize many things, because it knows that read-only mode is something that can be much easier optimized compared to when things could be modified. Therefore, many optimization techniques are simply not available if we don't use constants or read-only modes. So this is just something that this slide is talking about. So here we have an example of print point, where we pass point as a parameter, and of course there's no reason to make copies of this point. We just simply say, okay, this is your point, and it's a reference to constant point living somewhere else. So when we make a call into this function, we simply say print point whatever, point x, and the copy will not be made. We use the original object, and we also will continue using it in read-only mode. So this is the set of topics specific to const reference in function arguments, like we've had in our example here of the string implementation as well.